Hello everyone and welcome back. I am Mr. Cobalt and today we are going to be going over mass percent composition. In the next video I'll talk about how we then are going to use that as a conversion factor. But we need to know what it is to begin with. So the first thing we need to talk about is what is a percentage, because that's going to apply to percentages, all percentages. So when we're talking about percentage, what we mean is we're taking some sort of part, we're going to divide it by some whole or total, and then we multiply that fraction that we are making, and we multiply by 100 to get the percent. So that's why we call it a percentage. Percent means per 100. So we take some fractional amount of something and we multiply it by 100. If we've heard of parts per million and parts per billion and things like that, same thing applies, but instead of taking the fraction and multiplying by 100, you're taking the fraction and multiplying by a million to get parts per million, or a billion to get parts per billion. But in this case, we just want percentage, so we're multiplying by 100. So to get the mass percent composition, that's where we're going to find out what the mass percent of an element is in a particular compound. So if we know what our compound is, we can calculate the mass percent of each element in the compound by first taking the molar mass of the compound of the element itself and then dividing by the molar mass of the compound. Now this is not the molar mass just of the compound, but it's the mass of 1 mole of the element. Okay, so I'll explain with an example, but this isn't, I'm just not writing down, not looking up on the periodic table and I say, okay, that's the molar mass. It's going to be the molar mass multiplied by, the number of the element X that I have. So if I have 2 atoms of X in my formula, then I'm going to take the molar mass multiplied by 2, and then I divide by the total molar mass of the compound. So I have 2 examples that I'm going to go over, and then don't forget you're going to multiply by 100 to get the percentage. Okay, so how do I find the mass percent? In this problem, I want to find the mass percent of chlorine in this molecule here. So the first thing I need to do is I need to know what the percent, I need to know how much of this is in my overall formula. So I have 2 chlorines. I'm going to look up the molar mass of chlorine in my periodic table, and that is going to be 3545. So I have the molar mass 3545, and that's going to be that many grams per mole, right? So I'm assuming 1 mole of everything. So that's going to be 35.45 for each mole of my chlorine. But how many chlorines do I have? I have 2. So I got to multiply that by 2, and then that's going to give me 70.90 grams for the chlorine. So I have chlorine that is in 1 mole of this substance. So I'm always assuming 1 mole. So for every 1 mole of this substance, I have 2 moles of the chlorine. So for every 1 mole, I have 35.45 grams, but I have 2 moles or 2 chlorines, right? So that's going to be 70.90 grams of chlorine that I have in my 1 mole of substance. So the molar mass. So it's the molar mass of the chlorine multiplied by 2 to get the total mass of 1 mole of chlorine in this 1 mole of this substance. Okay? So then, now I need to calculate what the total number of grams is for 1 mole of the complete formula. So I'm going to take the 70 because I need that for the 2. So it's going to be 70.90 grams of chlorine. And then I need to add on the carbon and the fluorine. So carbon is 12.011 grams per mole. And then I got to add in the fluorine, but I got to multiply that by 2. So fluorine is going to be something like 19. Let's look it up. Yeah, 19. So fluorine is going to be 19.00 grams. And I'm going to multiply that by 2 because I've got 2 fluorines. And then I add that together. And that's going to give me the total mass of 1 mole of my substance. So I'm calculating the molar mass of my substance. Okay, so I have 70.90 plus 12.011 plus 2 times 19 equals, and I get 120.911, and that's going to be grams per mole. So this is grams per 1 mole. This is grams per 1 mole. So now that I have the molar mass of, or the mass of 1 mole of my compound, and I have the mass of the total mass of of my chlorine in 1 mole of the compound. So now that I have the mass of the part and the mass of the whole, right, the whole, now I can put in my equation the part over the whole multiplied by 100. So then I take the 70.90 grams of the chlorine divided by the total here, 120.911 grams of the total, which is going to be my CCl2F2, multiplied by 100, and that's going to give me the percent mass or the percent composition of chlorine. So I take 70.90 divided by 120.911 equals, and I get, I got multiplied by 100 times 100 equals, and I got 58.638%. And so now I have to pay attention to my significant figures. So here I have 4 sig figs, 4 sig figs. Here I should have 2 decimal places since I'm adding these together. So that should be 2 decimal places. And then so I'm limited to 5 sig figs here because I have to stop there. And so if I'm dividing, then I have 5 and I have 4, so my final answer should have 4 sig figs here. So my final answer is 58.64%, and that's chlorine. So 58.64% of my substance is composed of chlorine. And I can figure out what the other percentages of the elements are by doing the same thing. So if I wanted to find carbon, I would just find out what the total mass of the carbon in 1 mole of this substance. Since it's 1 to 1, that's just be 1 mole of carbon. So I find that, and then I divide again by the total multiplied by 100. And that's how you find the percent composition of each element in your substance. So let's do another example. Here I have mass. They want the mass of chlorine in Freon 112, and here's the formula. So I do the same thing. Now here, in 1 mole of this substance, I have 4 moles of chlorine. So in order to get the total mass of the chlorine in this substance, I have to multiply by 4. So I take the mass, the molar mass of chlorine, or the atomic mass, which is the same thing, 4, 5, right? Since I have 4 chlorines, so I'm going to multiply by 4 this time, and so that's going to give me 141.8 grams of chlorine in 1 mole of this substance here. So that's going to be the total mass in 1 mole of my substance, because 1 mole of this substance is going to give me 4 moles of the chlorine. Or another way is one molecule of this gives me 4 atoms of chlorine, which translates into moles too. Okay, so the next thing I'm going to do is, now I need to figure out the total molar mass of 1 mole of the substance. So I take the 141.80 grams due to the chlorine. Now I'm going to add to that the carbon, so I have 12.011 times 2, because I have 2 carbons for every 1 of these. And then I'm going to add to that, I have fluorine again, so that's going to be, again, 19.00 multiplied by 2. And so now I just need to calculate this, so 141.80 plus 12.011 times 2 plus, and then I have 19 times 2 equals, and so this gives me 203,822. So 203,822. Is it 822? Yes, 822. And this is grams of the whole substance. So C2Cl4F2. So now, once again, I have the mass of my, or where is it? Yeah, so I have the total mass of the chlorine in my formula in 1 mole of this substance. So that's going to be the part that I'm looking at, because I need the mass percent of chlorine. And then now, and then I have the total molar mass of 1 mole of the substance, which is here. And so once again, I do my part over the whole. So I'm going to write that up here so I have more space. So the part is going to be 141.80 grams of the chlorine divided by 203.822 grams of the whole substance, C2Cl4F2. Okay, so now here, and then I multiply by 100. So again, you get your calculator out. You got 141.80 divided by this number here, multiplied by 100 equals, and you get 69.5705%. But once again, you have to pay attention to sig figs. So here I have 5 sig figs, here I have 6, so I'm only allowed 5. So I have to cut it off here. Okay, so then it would be 69. That is what I would keep, and this would be a 1. Okay, so I hope that was helpful. Like the video, share the video, subscribe to the channel, make a comment if you have any questions. I'll see you next time.